So we built a basic implementation of our controller and our service. We also connected our application to the database using JPA repository, and we constructed some models to be able to communicate with our database, as well as communicating within our application using entities and using DTOs. But now it's time to dive into the security portion of our application using Spring Security. So we'll spend some time setting up the security portion of our application. It's going to be a good amount. This is why I kind of saved it for the middle portion, because it is going to take a good amount of time to explain what is going on when it comes to the authentication and authorization filter. But the gist is we only want logged in users to be able to communicate with most of our application. And when I mean most of our application, I mean in the case where a user needs to log in or sign up, they're not going to need a JWT token. But everything else, for the most part, they are going to need a token. So we'll set up Spring Security to utilize JWT authentication, and that's why I have this arrow pointing here. We're going to need to set this up. Now, the two dependencies we're going to need for this portion of the application, for the security portion, is Springboot Starter Security and JWT, which is going to help us encode and decode our JWT tokens. So here I am back in application, and I'm going to go right under in the dependencies in the pom.xml and add those two dependencies that I need. So like I said, I'm going to need Spring Boot Starter Security, and I'm going to need JWT to handle the encoding and decoding of our JWT tokens when it's time to provide them and when it's time to retrieve them from the user and actually grab information from it. So I'm going to add those two dependencies, and you can check out the repo of where this is to try to see which version you actually need. Right now, at the time of recording this, it's going to be 0.9.1. That fits me. We got to find out which one works for you. Then go ahead and click that Maven button up above so that it can go ahead and start retrieving those dependencies. Now, when it comes to logging in, we already have the login DTO. We're going to use this DTO for our request so that when a user logs in, we're going to need the email and we're going to need the password, and we're going to pass that information on to Spring Security to make sure those values are proper, and then it will generate the JWT token to provide back to the user so they can use that for any other requests when interacting with our application. So at least we already have that portion done. So the next thing that we're going to need to create, because we already have the login DTO, we're going to need to create a class called user security. And this is going to inherit from the Spring Security user details. And let me go ahead and create that, and I'll go over what exactly that actually means. So let's go ahead and create user security. All right. And that's going to be in the models folder. If you want to create a subfolder called Spring Security or Security and place that in it, you could. I'm just going to leave that directly in the models folder. All right. And then in there, all we got to do is inherit from user details. And then go ahead and import it. And it's going to be coming from the security.core. Now, what is user details? I'm glad you asked. Now, as we saw, user details is provided by Spring Security. It will store information which is later encapsulated into an authentication object. This will allow non-security related user information such as email address, telephone numbers, etc. to be stored in a convenient location. In our case, we're going to accept a ID, an email, a password, and user authorities. User authorities is simply going to be roles attached to the user, whether they're normal users, admins, or any other type of roles. But you can also see that there are other methods that user details provide. We can check if an account is expired. We can check if an account is locked. Is the credentials expired? Is it even enabled? These are all the additional methods that user details provide straight out of the box from Spring Security. Now, because we're inheriting from user details, we do have to go in and override some of the methods from user details and pass in some values. So for user security in itself, though, like I said, we're going to accept in an ID, right? And I'm going to make that nullable. And we're going to pass that through the constructor. So let me just open that up a bit. We're going to need an email, and that's going to be of type string. We're going to need a password. So I'm going to call this val user password. And let me change that to lowercase. And that's going to be a type string. And we're going to need the user authorities, which is going to be the roles that I was just discussing, right? Whether you want to add, whether a user is admin or whether they're a regular user, you can do that. And that's going to be a collection of granted authority. So I'm going to do mutable collection, meaning it can change, and it's going to be holding granted authority. So it can have multiple roles, right? And then within user details, we're going to have to override some of the methods that are provided by user details. So I'm going to go ahead and copy it in, and then we're going to go over what exactly it means. So let me paste it in. What this is going to do is we're overriding get authorities. We're passing the values of user authorities directly to it. So when we're doing get authorities, it's going to provide the user authorities that is associated to the user. It's going to get the password. It's going to get the username. And in this case, you have a decision that you can make here, right? For username, in our case, username is going to be email. If you use the actual username in your database for user, meaning you're actually taking in a username, then this constructor value would have to change to username, or maybe you might want an additional constructor value of username and pass that value here, right? Because we're assigning the user details, right? So we're assigning the password, we're assigning the roles, and here we're assigning the username. In my case, I'm going to let the user use their email as a username. But like I said, if you have a username field for it, then you have to pass it here. Now here you have to define, whether an account is non-expired, which is in this case, I'm going to automatically set it to true. Now, if you want to add some additional logic to do that, you can. You just have to do the logic internally here, and then you can, provide that value here. But in this case, I'm providing boolean of true to all this by default. So the account is not expired, the account is not locked, the credentials is not expired, and this account will be enabled. But like I said, if you want to add some additional logic to this class to determine whether any of these values is true or false, then you can do it from here. So now we have the user security that is inheriting from user details. Like I said, it's just another way to encapsulate information regarding the user and have it stored somewhere to be retrieved. Um, and then now what we can do is we can create a service layer for the user details, which will allow us to load the information that the user has stored. And this will be needed for the authentication piece. We need to grab information about the user, and the user details has it, right? It has the username, it has the password, it has the roles. All the information is encapsulated in this class that I just created. All right, so now that we have the user details established, let's go ahead and create a service for the user details. So let me right click on service. That's a service layer. Create a new Kotlin class, and I'm going to call it user detail service. And you already know the deal. Use the service annotation and to let Kotlin know that this is a service. And what we're going to need to do is first inject the dependency that we're going to need in this user detail service, which we're going to need to grab information regarding the user. So it makes sense to use the user repository to interact with our database. So we're going to do private val user repository and import an instance of user repository. And then we're going to extend the user detail service. And this is coming from Spring Security. And just like before, we're going to have to override a method provided by the user detail service. And that will implement the logic to retrieve the user detail. Because remember, we created this user security class that stores information regarding the user details. And what we're going to need to do is use this service layer. When the user signs up, it's going to grab the details of the user, and it will be used to authorize the user when the user attempts to log in. We will need it to grab the user details to compare, right? To compare if the user is actually the correct user, right? Is the email proper? Is the password proper? This is the starting location for that. So let me go ahead and do that. Let me override. And honestly, you can just hover over it, or you can just start typing with IntelliJ. It knows that. And I'm gonna press enter here. And you can see that it essentially pretty much creates that override function for us. We just have to implement the logic for it. But the override method that we're going to need is the load user by username. And remember, like I said, we specify the username here. Whether you have a separate field or whether you use the email is really up to you. But in my case, I'm using the email for the username. And you would have to specify that by passing it through the constructor and assigning that value as the username. So back to the detail service. I'm gonna have to implement this really quick. And in my case, it's not username. Well, it still is username, but I'm gonna make it more specific and say that it's an email, right? We're gonna need the email to load the user by the username, right? Because the email is the username. Now to load the user by the username, or like I said, the username is gonna be the email. I can utilize the method that we created before in the user repository, which is find by email, right? This was intentional. Like I already knew beforehand that we're going to need the email to log in and created a custom method for that. And I can use that to find if the user is actually an actual user, right? If that user exists by that email. And to do that, what I can do is create a variable and have it store that information regarding that user. So I can do user repository dot find by email, pass the email, and remember this is an optional, right? So there's many ways that we can go about doing it. We can do dot get, and that would just attempt to get the value from that optional. It can either be the user or it can be null, right? Meaning that user doesn't exist by that email. Or like we saw before, we can do an or else throw, right? So I can go ahead and throw an exception. So what I'm going to do here is I'm going to throw an exception, right? I'm going to throw an exception saying that the user is not found. And we're going to clean this up later on because right now it's just going to throw a very generic exception. I'm just going to put user is not found. And right now this will cause a lot of problems in my application. But like I said, in the future, we're going to create a global exception handler. We're going to create a custom exception for this. It's going to be called the user not found exception. Not very creative, but it's effective. And it will return a message as well as the proper status code if a user is not found. But for now, I'm just going to return a generic exception. Just stay tuned for the global exception handler coming up soon. Then after that, after we confirm that the user actually exists and the exception wasn't thrown, we can go ahead and return an instance of the user security, right? Which is pretty much holding an instance of the user details. So we can do user security, import that in, and we're going to create an instance of it by passing in the values to the constructor. So before, we specify that the constructor is going to first take in an ID, provide the user ID, the user email, which in this case is going to be the username, and then the user password, right? And then also lastly is going to be the role, right? It's going to be the granted authority. Now here, if you want to add some logic of, you know, who deserves what role, it's really up to you, right? You can have another database that stores the roles, right? That can be a many to many with the user, and you can retrieve the roles and pass it here. But for this application, I'm just going to do a collections dot singleton because it's going to be a single role, and I'm going to give it a simple granted authority of type user. And I got to import both of these. So I got to import simple granted authority from the Spring Security library, and then I got to go ahead and import collections. Now remember in the user security, right, there's an option, right? There's an option to provide the user authorities, and then that will be provided to the user right here by get authority. So we can then in the future, if we wanted to, get the roles that the user has. So if by chance you provided admin or if you provided a moderator or whatever other type of role, then you'll be able to get that authorities from the user details. But in this case, I'm just providing a single role. So like I said, if you want to create a separate uh, correlation between roles and username, and then above here, you can retrieve those roles and then maybe create a separate collection, iterate through them, and then provide it to the user security piece here. You can do that. But in this case, I'm just going to provide a single role. But at least you guys know how to do it if you want to, right? All you have to do is grab the roles, right? Maybe you had a separate uh, controller endpoint for roles, right? Maybe you did it manually, right? As a DB admin, you added a role to a user manually, and then now it's just really just querying the database or querying the roles table, and then providing those roles on sign in. But if you need any more assistance with that, just let me know. So now that the user detail portion is done, we pretty much have the starting point of generating a JWT token for a user. Because what this is going to do is first it's going to check, is this user even signed up? Because we already have our separate endpoint. We're the one that's handling sign up, right? We create a user and we have let me go back to the service, the user service that will save a user, right? We're going to need to create an endpoint that saves a user. And then from there, we can go and let Spring Security handle the sign-in process. So from here, we can confirm if the user even exists in the table, the user's table. And then from here, it's going to start the process of loading a user and confirming whether their email and their password matches up. And then it will provide a JWT token. But you have to set that up as well. Now, I've been saying JWT token a lot, but what is a JWT token? Well, JWT stands for JSON Web Token. A JSON Web Token is an open standard RFC 7519 that defines a compact and self-contained way for securing transmitted information between parties in a JSON object. So here on the right, I have JWT.io. It's pretty popular when you want to see what's inside of your decoded JWT token, and you can see what's inside if you provide the secret, which I'll talk about soon. But on the left side, which is the encoded side, is the token itself, and on the right side is how it would look like when it's decoded. So there's a structure to it, right? The structure is there's a header, there's a payload, and then there's a signature. So like I said, this information can be verified and trusted because it is signed, right? JWT tokens are signed using a secret. And to see what's inside of it, well, you need the secret. Now, when it comes to tokens, right? Tokens are credentials. Great care must be taken to prevent security issues. In general, you should not keep a token longer than required. Some applications make JWT token expiration times very short. Some make it a little bit longer, but it shouldn't be too long. Now, like I said, there's a structure to these tokens. Now, the header typically consists of two parts: the type of token, which is JWT, and the signing algorithm, which can be either HMAC, SHA-256, RSA, or even in this example, HS-256. The second part of the token is the payload, which contains the claims. Claims are simply statements about the entity, right? So in this case, the entity is going to be the user, right? So that can be the user's name, the user ID, or any other additional data. And there are three types of claims: registered, public, and private claims. The third part is the signature. To create the signature part, you have to take the encoded header, the encoded payload, and the secret, right? The secret is very important. You got to make sure that nobody has it but you. And the algorithm specified in the header, and sign that all together. The signature is used to verify that the message was not changed along the way. And in the case of token signed with a private key, it can also verify that the sender of the JWT is who it says it is, right? So like I said, the secret is very important to make sure that you encode the token, but also when it's time to decode the token, you have that secret to do that. So you want to make sure that that secret is, first of all, very long and powerful. And second of all, that nobody else has access to it. Because if anyone else has access to that secret, then they'll be able to see all the information inside of that token. So how to use a JSON web token and why? So whenever the user wants to access a protected route or resource, the user/client should send a JSON web token, typically in the authorization header using a bearer schema. So the format is right below. It should be the header of authorization, and the value should be bearer, a space, and the actual token value. And I discussed how to create a JSON web token before, right? You need the structure of the header, the payload, and the signature. You're going to need that secret and provide it an expiration time. The secret is important. You want to make sure that it's secure and not easily accessible. The expiration will determine how long the JWT will last before it is invalid. Making it too long is not good, but also making it too short is not good as well. You got to find the right length of time to make the JWT valid because it is important as well. We do not want someone stealing the token and using it because you made the token last a month. I've seen tokens last 15 minutes, but for banking, it's typically short because you want to make sure that the user, gets what it needs to from the account, but then after that, log the user off automatically. So typically when you use like a mobile application or even on desktop, when you use your banking application, it usually runs a timer to pretty much log you off automatically. So in that case, it will invalidate that token, and then you have to log in again to get a new token. So there's different security measures that different applications take to make sure that a user is secure and that the user is who they say they are. All right, so we're making some traction, and let's continue on with that traction by creating a utility file. This utility file will be used to generate a JSON web token. And that's very important because we're going to need the token to pass to the user. So we're going to create a package called utility, and we're going to create a class inside of that utility package to generate the token. And it's also going to do some other JWT related tasks, such as getting the claims, getting the user ID from the JWT token, checking if the token is valid. All of that is going to be within the JWT utility class. So let me go ahead and right click on the parent folder, hover over new package, and I'm going to call this utility. Now in this utility package, I'm going to right click, create a new Kotlin class, and I'm going to call this JWT utility. Now you're probably thinking, okay, this is not a repository, this is not a service, this is not an entity. So what exactly do we use as an annotation? We're so used to putting annotations at the top of classes. What can we use in this case? Well, luckily Spring Boot has another annotation that we can use called component. And the component annotation, and let me just write it out real quick, at component. Press enter, and here it is. So with the component annotation, it tells Spring that we're going to need an instance of this class to be created when the application starts up. So yes, it's not a service. Yes, it's not a controller. Yes, it's not a repository, but it's still a class that we're going to utilize throughout our application using dependency injection. So to make sure that it's there and readily available, we got to make sure that we apply this annotation to make sure that Spring knows that this needs to be created when the application starts up, and I should have access to it to inject in my application. So I may use this in the service, I may use this in the controller. This utility class is going to be very important for validating tokens, for grabbing claims. So this will be injected in many places. So like I said, in this file, we're going to create methods to help us with our token, such as generating a token, extracting data from the token, checking if it's valid. But before we can do that, let's go into the application.properties because we need to define the secret. I'm always talking about this JWT secret and how we have to keep it hidden and away from active eyes or making sure that nobody has access to it. I'm going to put in my application.properties. And so let me head over to the application.properties. And let me go ahead and add a variable really quick. So I'm going to call it funds underscore app dot jwt dot secret, secret with an E, is going to be equal to thanks for watching. Now, the value of the secret should be way more secure than thanks for watching, but I also just want to say really quick, thanks for watching. Well, another disclaimer is that placing a secret can be very dangerous in the application.properties as well. There are multiple ways you can keep the secret secure. If you're using cloud services, there are dedicated services such as vaults, where the application can retrieve the secret from the vault. With the application.properties, you have to be careful because typically it gets pushed to a coding repository like GitHub. You do not want your secret sitting in a repo. You can make dedicated configuration properties that are excluded from the code repository. But for the sake of time, I will place it in the application.properties. But as I usually do, I just want to provide a disclaimer on why you may want to think twice before putting it in the application.properties for production-based applications. At least we have a value for the secret, and like I said, it probably should be more secure. But just for this demonstration, I'll keep it simple. But there's plenty of places where you can generate a very secure secret. Um, but just for this demonstration, I'll have it as thanks for watching. Now going back to the JWT utility, I want to be able to retrieve the secret from the application.properties. And that's pretty simple. All I got to do is use, guess what? Another annotation. And this annotation is going to be called value, right? And what I can do is I can specify the name of the value of the variable that I'm trying to retrieve. So in this case, what I'm going to have to do is I'm going to open up a string, use a backslash, use a dollar sign, open up some brackets, and place the name of the variable that I'm trying to retrieve from the application.property. So in this case, it's going to be funds underscore app.jwt.secret. Now you're probably wondering, why is there a backslash? Because I was asking the same question when I first started this process, right, of utilizing values from the application.properties, and there's a reason for that. Now this dollar sign with open brackets is a special Spring syntax. It's indicating property placeholders. So although we are used to expressions in Kotlin and injecting springs using this syntax, Spring utilizes it in a different way. So we need to make sure it includes this whole expression, right? It's not just simply injecting, just this piece of a string. It actually needs this whole syntax for Spring to understand it, right? What exactly we're doing. And in this case, the syntax is dollar sign, open brackets, and the value of the property that we're trying to retrieve. And then after that, what I got to do is I got to provide a variable that this property is going to be injected into. So what I got to do is late init var, and I'm going to call it secret. I'm going to call it all caps secret, and it's going to be a type string. And I got to use that, a lowercase t. If you don't have a background with Kotlin, late init is just simply telling Kotlin, like, okay, we're eventually going to place a value into this variable. Believe me, eventually this is going to be populated with a value, right? It's going to be initialized late, but eventually it will be populated with a value. So yes, we're going to retrieve a value from the application.properties, and eventually it will place that value into this secret variable. So that's why late init is used in this case. The second thing I want to create is the expiration time. So I'm going to do private val, and I'm going to do expiration underscore milliseconds, because it's going to be in milliseconds. And I'm going to set it equal to 600,000 milliseconds. And that's 10 minutes, right? So that's 10 minutes. So 600,000 milliseconds is 10 minutes. And that's how long I want my JWT token to last, 10 minutes. Now, if you want to increase it or if you want to decrease it based on your application needs, you can do that. But in my case, 10 minutes should be fine. All right, so now for the fun part, I'll now create a generate token function, which, as the name implies, is going to generate a token, a JWT token. And the parameters that I'm going to provide is first the user ID, which is going to be of type long. And second is going to be an email, which is going to be of type string. And I'm going to open that up. And this is going to return a token, so it's going to be of type string that I expect to return. And then I can open this up and begin the process. Now, so you're probably wondering why I'm using email and user ID as parameters for generating the token. Well, first, when we generate the token, we're going to be generating the token through logging in. And the email is already readily available, so why not, right? But secondly, the user ID, which is going to be the most important thing, is going to be used for validating whether or not a user has the ability to work with the application when it comes to things like deposits, withdrawals, sending money. We're going to use that user ID, or we're going to retrieve that user ID from the token to make sure that that user even has the ability to do that. And we can grab the accounts associated to that specific user. So the user ID is very important. And we can't just use email because of the fact that the user can change their email in the future. We may not build that in our controller specifically, but if you're building your own implementation, or if you're building this for work or any side projects, then you have to think about the fact that an email can change in the future. So a user ID will be more secure because a user ID will stay the same no matter what. But it is still useful to have it, just because when generating the token, we're going to have access to the email anyway. So you don't need the email. Like, it's not a requirement to use the email to generate the token, but I just have it because it's readily available. Most of my queries are going to use the user ID though, because like I said, it is the unique identifier for a user and it's not going to change. So that's usually what I'm going to use for the queries. Now, to generate the token, I'm going to use the JWTS builder. This is coming from the JSON web token dependency that we retrieved earlier, right? We used the Maven to retrieve that dependency. So let me begin that process of using that builder. First, what I got to do is get the value of now, right? And I'm going to make that equal to date, right? It's going to grab the current date, right? The current time, the current date. Grab that from the JWT library. Now, why am I grabbing the current time? Well, remember this expiration time, right, in milliseconds. We're going to need to grab the current time and add on that expiration time to give a window of how long this JWT will last, right? We're going to create the expiration date. So it's going to be the current time plus the expiration time in milliseconds to create or to set the expiration time. So the next line will be file expiration, and it's going to be equal to date of now dot time plus the expiration in milliseconds. So it's going to grab the current time plus add on the expiration time. So 10 minutes from now, the JWT token will expire. So this is why we're creating an expiration variable, and we're going to add that to our JSON web token when we're building it, because we're going to be using the JWTs builder to build a token. So once this person logs in and it begins the process of generating a token, it's going to grab that time, add the expiration, and then it's going to add that to the token, and that token will expire in 10 minutes. And what are we returning? Well, we're going to return an instance of a token, right? It's going to be a string. We're going to have to build that token really quick, and we're going to use the JWTs from JSON Web Token .builder, and we're going to have to start building the process of a token. Now, let me break it down, right? The first thing that we're going to need for this builder is the subject. Now, if you go back to when I was describing a JSON Web Token, there's a structure to it, right? The subject is used to provide some basic information about the context in which the JSON Web Token was issued. Typically, it represents a unique identifier for the user or system that this token is going to be associated to. Now, the thing is, it has to be unique. And in this case, likely we have something that's very unique, and that is the user ID, right? The user ID is very unique. The email is also unique as well. We can use the email as a subject, but in this case, I'm going to use the user ID. Either or is fine though. But like I said, things do change. I don't like the fact that the email can change if a user wants to change it, but the user ID is not going to change. That's very unique, so I'm going to use that. Now the thing is with the subject is that it has to be a string, so we're going to have to use toString on this to make it valid. Now it's still going to be angry at me because we still have a lot of things to build, but that's just the first part of the process, right? The second thing I'm going to add on to this JSON Web Token is a claim. I'm going to add multiple claims actually. Claims are pieces of information asserted about the subject, right? The subject in this case is the user, right? The user ID is the subject, and now we're going to add on claims that associate to that user. And we also have information about the user in this case as well. We have the email and we have the user ID. So what I'm going to do is I'm going to use .claim and start adding claims to this web token. Now, the claim expects a key and expects a value, right? So the first thing I'm going to add, or the first claim I'm going to add, is user ID. And the value is going to be, of course, user ID. And honestly, let me just bring this down. All right. And then the second one I'm going to do is another claim. And it doesn't like when I've used tab, apparently. Okay. And then it's going to be email, right? And I'm going to pass in the email as the value. So that's easy information about the user. The next thing I'm going to set is the expiration time. So it's easy. Just set expiration. And we're going to provide that expiration variable that I created above here. All right. Last thing that we got to do, because I already add the claims, I add the expiration. That's really all I want to do for this token builder. But the last thing that needs to be done will be signing the token, right? We talked about that process as well, but signing the token with an HS512 algorithm. Now I'm not a crypto head, but it's a pretty secure algorithm. So to do that, I got to do sign with, and I got to specify the algorithm that's going to be used. So I'm going to do signature algorithm, and luckily that's already provided by the JSON Web Token dependency. So what I can do is signature algorithm, and you can see that it has a lot. So you can do your research and see which one fits your needs. But I'm going to do HS or dot HS 512. Then after that, what we got to do is we got to pass the secret as a byte array. And I got to first import this as well from JSON Web Token. And then second, I'm going to provide the secret as a byte array. So we have the secret above here, and it's all caps, secret. And to convert it into a byte array, you can just do dot to byte array, right? And then after that, it's still returning some swigglies because this is not what it expects, right? It expects a string to be returned, but if I hover over this, it's going to be still a JWT builder. That's the problem. And likely we have a solution, and that is to use the dot compact method, right? And this is just going to return a compact URL safe JWT string. And as you can see, it's happy now. So now we have a method to generate a token. In the process where we need to retrieve information about a user, right, who has a token, right there, they logged in, they have this token, they're hitting our API, and now we need to validate that JSON Web Token. Well, we need to be able to grab information about the user from the token, from the claims that we just set. So we need to be able to grab the user ID, we need to be able to grab the email, and we're going to need to create a method to be able to do that, right? So first I'm going to create essentially a private helper method to get the claims from a JWT token. So what I'm going to do is I'm going to create a private function, and it's going to be called get claims. And what I expect to pass to this is the actual token, and that should be a string. And what should I expect? Well, I should expect to return claims, right? But there is a case where issues may arise, and whether or not that JWT token is a fake token or whether it expired or any other issue, there may be a case where no claims are returned. So I got to make this notable. And let me go ahead and import claims from JSON Web Token and open that up. Now, what I want to return is claims, right? I'm going to try to return claims. What I mean try is, like I said, things can occur, right? Errors can occur. So I'm going to need to wrap this process in a try and a catch because errors can arise and I want to make sure that I handle those errors properly. So I'm going to try, and within here, I'm going to try to retrieve the body of the claims. And to do that, I'm going to use JWTs, just like before, but instead of using the builder, I'm going to use the parser, right? And just like how we use the signature to sign it, right? We're going to need to use the signature to retrieve information from the token. So what I'm going to do is I'm going to set the signing key to the secret, capital secret, dot to byte array, right? And then I'm going to dot parse claims JWS, right? And I'm going to provide the token, and then I'm going to grab the body, right? So this will retrieve the claims inside of the token. Now, I still got to finish up the catching portion, right? So there's usually two common exceptions that can occur with the JWT token process of trying to retrieve, the claims from the token. And the first one is just a simple catch of a JWT exception, meaning someone attempted to send an invalid token, and well, when trying to retrieve the claims, there was an issue. So we're gonna need to process that. So I'm gonna just print it out. You can have a monitoring service here. Maybe you may want to send that to the monitoring service, and that can do something that can alert you, or uh, you may want to run some logic to do something inside of this catch. In my case, I'm just going to print out the error, but after that, I'm just going to return null. Because if I'm attempting to grab a claim and it returns null, then I'm just going to return back to the user that this is an invalid token. We're unable to process it. We're unable to let you move forward because this token is not valid. Go ahead and log in again. So this null is pretty much going to tell me that message that we got to this point where we see that this token is not valid. Go ahead and let the user know that it's not going to go through. This is not a valid token. And the second common exception that can occur is an illegal argument exception, which just means that it may have been a malformed token. So I'm going to go ahead and handle that by catching it, and it's going to be held in a variable called E, and it's going to be a legal argument exception. There it is. Open that up, same process. I'm just going to print out the error. Like I said, if you have um, a process that's going to be used for handling when someone is attempting to utilize your application with a malformed token or just a straight up wrong token, you can add that logic before the null. It's up to you. But in my case, I'm just going to print it out and I'm just going to return null so that I know that, okay, we're not going to be able to process this and we're not going to be able to retrieve the tokens because this token is not valid, right? There's something wrong with the token. And then I always add like a general exception at the end, just in case that, it's not a JWT exception or a legal argument exception. Then I'm just going to return a very generic exception. Same concept though. Print out the exception and then return null. Still not going to let the user go through. We're not able to grab the claims from the token. It's not good. So now you see why claims is nullable, because yes, there is a good case where we're able to grab the claims and return it back, return the body. But then there's a case where there's an exception and it's going to return null. So, and when it does return null, then we have to process that properly. Now, how will we be utilizing this get claims helper method? It's a helper method within the helper class, right? It's pretty funny, but we're going to be utilizing it for two specific methods, which is first going to be get user ID. And what we're going to do is we're going to accept a token as a parameter. And what we expect to return is a long because the user ID is a long. And what we're going to do is we're going to make that equal to get claims, and is going to pass the token from this function that we retrieved it from, pass it to get claims. And what it's going to do is we're going to have to use a safe way of getting the user ID, because remember, this is nullable. So what I'm going to do is utilize the safe call operator that Kotlin provides to attempt to get the user ID from the body, because remember that if it is actually the claim that's being returned is going to return the body, and within the body is going to be either the user ID or the email. And in this case, what I'm going to do is I'm going to attempt to get the user ID, and it's only going to get this far if this value is not null, right? If it's not null, then I can get the user ID from the claims.body, because the body is being returned from the get claims method. Now, if it is there, then I can use the .get and it will get the user ID. And what I got to do is I got to convert it to a long. Now, if it is not available, then it's just going to return null. Now, the second method is about the same process, right? And I'm going to just copy this to save time, because just like how I'm retrieving the user ID, I'm going to get the email, right? Same process, get email, and I'm going to accept the token as a param. In this case, it's going to return a string because email is a string. And instead of grabbing the user ID, I'm going to grab the email and I'm going to return that as a string. So we have a helper method for getting the user ID and getting the email. So now we have helper methods for getting the user ID and getting the email. The last method that I want to create is checking if a token is valid, right? So I'm going to call this function is token valid. It's going to accept a token, which is going to be string. And this was just going to return true or false. So it's going to be a Boolean. Open that up. And the first thing I want to do is I want to grab the claims, right? Because if I'm able to grab the claims, that means it's essentially a valid token, right? So I can return true if I'm able to retrieve the token, right? Meaning it's not null. Because if it's null, then that means that we're unable to grab a value from that token, meaning there's an issue with that token. It's malformed or it is just not good. So send that token value from the param down to get claims. And now what I'm going to do is I'm going to do return if claims is not equal to null. What I want to do is open this up. Now, if the claims that we retrieved is not null, that means we can move on to the next step of validating this token, right? Because we still got to check if it is expired or not, right? That's still important. And we set the expiration here, so we still have access to that through the claims. And to get that, all we got to do is first, I'm going to create a variable called expiration date, and that's going to be equal to claims dot expiration. And I'm going to use a safe call here too as well. And what I'm going to need to do is also grab the current time, and I'm going to make that equal to date, and the current time I can use system dot current time millis. So now I have the expiration date, and then I also have the current time. If the current time is beyond the expiration time, that means it's expired, meaning that token is invalid, and we're going to have to return false. And to check that, it's pretty simple. I can just do now dot before, right, expiration date. Now what this is going to do is pretty self-explanatory. It's going to check if now the current time now is before the expiration date. If that is true, then it's going to return true, meaning it's still valid, so we can return true. Now, if now is not before the expiration date, that means it's after, meaning it's expired. So we can return false in that case. So this fits the bill. Now, still angry because we have to handle the case of the else, right? Because this is an if, meaning that if the claim is not null, then we can check the expiration time. And then this last piece is going to return true or false. But there is the case where claims is null, so we can do else and just return false. And with Kotlin, we don't have to put return. It's just placing the last value, and it's going to return that value. So we have the full JWT utility class. We have a way of generating a token, and we use the JSON Web Token dependency to use the JWTs builder to generate a token. We're able to set a subject, able to create a couple of claims to identify a user using the user ID and the email. We set an expiration, and we signed it with the secret that we injected into this utility class from our application.properties. Secondly, we made another helper method called getClaims, which will help us get the items from our JWT token, right? So we're going to utilize our secret to retrieve those values from the token. And if there's any issues that arise while trying to get those values from the token, then we're going to make sure that we capture that exception and return null, because we're going to use this getClaims method with our other methods such as getUserID and getEmail, which will be able to retrieve the user ID and email from claims only if we're able to actually get a value from the claim of the token. And then lastly, we created a helper method of isTokenValid to make sure that the token is actually valid. And it seems like I was a little bit too safe here because I used a question mark when I'm already checking whether or not claims is null or not. And we don't have to use a safe call operator if I'm already checking if it's null or not. So remove that. But we're able to use isTokenValid to check if a token is valid. And another way of checking if a token is valid is not only by retrieving the claims, but also checking if the token is still within the range of time that we provided, right? If it's expired, then we can't use that token anymore, right? It will make that invalid. So we checked if the current time is before the expiration time. If it's beyond the expiration time, then it's invalid. We're going to return false. And if we're unable to even grab claims from it, meaning there's an issue while trying to grab claims from it, whether it's a malformed token or whether there's an exception or any other type of exception, then we're going to return false. So we have the full utility class for a JSON Web Token. Now we can go over what is authentication, what is authorization, and dive in deeper into Spring Security. Now, everybody makes mistakes, and I realized that I made a mistake, and that's in user security. So in user security, I set the ID to be nullable. In this case, it shouldn't be nullable, right? I kind of confused it in the sense that entity is usually the ID is null, but in this case, we're providing it the ID, so it should already be populated. Now, going back to the user details service, I have to be able to handle the fact that I'm making this constructor value of ID not null, right? I have to be able to check beforehand if the ID is null or not. Now, if we actually get a value of user back from the users table, then I should expect the ID to have a value, right? That means we save the user and the ID is populated. So that just means that we have to do some checking before actually returning the value to place that value into the constructor. And by default, the user entity's ID is nullable. Remember, we use the annotation to generate the ID for us. And because of the fact that we're letting it generate the ID for us, we had to make it nullable. And you know that Kotlin is very serious about checking if a value is null or not, or handling null values just in general. So let's do that really quick. We're going to use the let function that Kotlin provides to check if the ID has a value. And we can do that by doing user.id question mark dot and then use let, right? And then we can open up this scope to then return the user security. Now, this will safely execute code only if the field is non-null. So it'll only run this if it is non-null. But then we'll have a fallback, right? If it is null, then we'll use the else operator to then run another separate section of code. So we'll throw an exception at that point, pretty much stating that the user is not found. And as you can see here, it's still angry at the fact that, okay, this is still returning a nullable field. Well, because we're in this let scope function, we have access to a thing called it, right? And it is just being the value that's being returned from this user.id, right? It's going to check if this ID has a value, and then if it does have a value within the scope of code, it is going to be assigned that value that we checked for, and we can pass it into constructed value. So in this case, it is just ID, right? The non-null value of ID. And then if it is null, then it's going to fall back to this piece of code, which is just going to throw an exception. And we're going to have a custom exception, like I said, to throw a user exception. Now, it's really not needed because we know that if we're retrieving a user from the user repository, it should have an ID. But just because Kotlin is very serious about no values, I use the let function to check if that ID is populated and then providing that value to the user security ID constructor value. And then from there, we're good to go.